We've talked about why we want to use object-oriented programming as a paradigm or architectural style for our programs, but I'd like to get a little more down into the weeds and really take a look at some concrete examples about how object-oriented programming benefits us as developers. Now, there's a lot of different features of object-oriented programming, and every different programming language, well, implements them a little bit differently. Some don't implement all of them, some do implement all of them, but in a slightly different manner than another one. So really what I'm going to focus on is what I consider the core basic feature of object-oriented programming, and that is the objects, right? It's object-oriented. It's got to be the objects. So first of all, let's talk about the fact that people often conflate classes and objects inside of object-oriented programming because every object-oriented programming language supports a class definition. But I'm here to tell you that these are two different things. I like to think of it in terms of architectural blueprints and the actual houses that you build from those blueprints. Your class definition is the blueprint itself, and the blueprint is not the house. When you create a class in your code, you create a definition called a class. You are creating a sort of basic blueprint or understanding of how to build something, and then in turn, you instantiate that class into an object, and it's that instance of your class that is the objects in object-oriented programming. That's really the thing that you're working with. And just like a house that's made from a blueprint, you can instantiate many instances, many copies of that house from that same single blueprint. So one definition, many objects. And those objects do not have to share the exact same properties across each one. Maybe one house has a brown roof, and another has a red roof, and another one has different shutters than the other ones, right? They are going to follow the same general basic structure and pattern, but there can be little things about them that are different from instance to instance to instance. Let's take a look at this in action. I think that'll help us understand it even a little bit better. Take a look at my Python code that I've got up on screen here. I'm creating three different, circles in this case, and each circle has an ID and a radius, a color, and a display. So in this imaginary program, I've got some circles that I want to draw on the screen, right? And they got to be a certain size and a certain color, and sometimes they'll be displayed and sometimes they won't. Well, down here, I then calculate the circumference of each circle and print it out using the formula for circumference of a circle. And you know what? Frankly, this code makes me a little bit ill to my stomach. It's terrible to look at. Look at the level of repetition in this code. I'm just looking at the same thing over and over and over and over and over. This is maybe very clear and understandable to read, but my gosh, there's got to be a better way to do this. After all, it's a huge violation of dry. Don't repeat yourself. I am repeating myself all over. Each one of these blocks of code is basically the same thing, just with different values over on the right-hand side. And this statement here is basically the same thing as well. I mean, I've got this formula for circumference written 3 times. What if I had a bug inside of my formula for circumference? I've got to go and fix it in 3 places. If I go and fix it in one and forget another one, well, I haven't really fixed my bug yet. So there's a lot of potential pitfalls in this code the way it's laid out. Now, conversely, consider this layout here. First of all, this code looks a little bit more complicated. It's more lines of code than it was before, and there's a whole lot more going on. There's this def thing here, this class at the top, and this init and circumference. But I've actually made my life a lot easier. I've simplified things for myself quite a bit. I have created a class definition up here with the word class, and I've called it circle. And I've indicated that circle has these variables associated with it, ID, radius, color, and display. And then this initialization function here, known as a constructor, gets executed whenever I create an object based on this class, which I do, for instance, right down here. I create an object, I name it circle1, and I give it an ID of 1, I give it a radius of 10, a color of blue, and a display value I set to true. So now I've got a circle1 object, an object called circle1, and I can replace, for instance, down here, I can say circle1 circumference is, I can replace this whole line of code with just circle1 dot circumference, open and close paren. Why was I able to do that? Because alongside of my circle1 definition up here in my class, I also defined a function called circumference, and circumference has that code, 3.141 times 2 times the radius. I have defined this function. It's called a method now that it's inside of a class, but really it's the same thing. A method is just a function that belongs to a class as part of the circle class. So now I can use it on my circle object, my circle instance, and I can get rid of this repetition of the formula. I can have the formula defined one time. Down here, I would say circle2. And lastly, I would say circle 3.circumference. So I've gotten rid of a whole bunch of repetition. Same thing with the creation of my circles. Instead of 4 lines of code for each circle that I wanted to create, each circle is created with 1 line of code using the same basic structure and formula. And actually, to be honest, since each of these circles has an ID parameter associated with it, I could get rid of these 3 print statements. I could put them inside of a loop and print out with a single loop and a single line of code the circumference of each of these circles. So there's a lot of advantages to be gained here. And there's some advantages in legibility, readability as well, right? This circle class, for instance, could be put out into a separate file, and I could simply import it at the top here. So I could say from circle import circle, and that would allow me to use the circle class here inside of my code while hiding all the muddy details in another file. Why is that great? That's great because once I understand what the circle class is and what it does, I don't need to clog up my file with that code. I don't need to clog up my brain with understanding how that works. I can look here and say, okay, I've got a mental model of what a circle is. I've got a mental model of what circle does in this code. Now I can focus on this code down here and understand what's going on with my program while more or less ignoring these first 15 or 20 lines of code. So that's pretty awesome. Let's talk about exactly what we've done here. When we created a class has 2 things going on. I'm going to get back now to the title of this video, which is state and behavior. A class in object-oriented programming, we're getting more abstract now, is really made up of 2 things, state and behavior. And I've split them up to make them easy to see here. State is everything up here, and behavior is everything down here. And when we talk about the state of our class in programming, we're not talking about New York State or the state of Texas or something like that. We are talking about state as in condition, like what's your mental state or what is the state of this circle. In other words, these variables, these properties represent the state of the circle. Down here, I create an object, I call it circle 1, and I give it, for example, a radius of 10. That circle now has a state of a radius of 10, and for the remainder of my program, any reference to circle1.radius is going to return the value of 10. If I later change the state of this circle to say 13, now I have changed the state of this circle. The circle's state has changed. And for the rest of the remainder of this program, after that line there, circle.radius equals 13, the new state will be reflected. It is going to remember that state, that condition, until I change it or until the program ends. So that is what we mean by state. Behavior, on the other hand, is the functions, the behavior, the code that can execute inside of our class. These are the behavior of our class. And I could have more. I've got init. This is a function that runs every time the circle is created. That's how this works down here. It's called a constructor. I've got circumference that I can execute anytime I want, simply by calling circle1.circumference. I could add as many functions as I wanted on down here and add as much additional behavior to this circle as I wanted. Maybe I add the function that actually draws the circle on the screen to the class, and I would call it draw circle. I could have anything in here. Any behavior that I wanted could be defined inside of my circle. Together, state and behavior make up a class definition, and every object in your code is an instance of state and behavior that you can use throughout your code. So that is how state and behavior come together to make object-oriented programming work. It is at the heart of object-oriented programming. Everything else, polymorphism, inheritance, implementations, interfaces, it all comes from these 2 basic ideas wrapped up inside of a class, state and behavior. I hope this has been informative for you, and I'd like to thank you for viewing.